Solve each system of equations below. I'll be honest, the first time I did this problem, I got it wrong, and I was going to leave that video, but unfortunately it failed to record, so I'm not going to pretend to get it wrong this time. I've learned from my mistakes. But what happened was I was just going along and solving this, and in the course of doing so, essentially what happened was I forgot that this was negative 7y. I treated it like a 7x, and I didn't catch that mistake until I was plugging in my values and seeing that the xy I got did not work as a solution. So it's a great advice is always just kind of check. Things happen. So as I look at this, I am going to use substitution. This is what I used the first time I solved it too, but I can see that the second equation tells me that whenever I see a y, that's the same thing as x plus 7. And my intent here is to replace y in the top equation, right, and it occurs twice there, with this x plus 7. So I'm going to use what we call substitution, right? So I'm going to go ahead and rewrite this first equation as 2x and then plus y, and y is just x plus 10, and then that's going to equal, I have not left myself enough room here, that is going to equal, negative 7 times x plus 10. So I'll go ahead and simplify this. There's nothing, this is just a positive number, right? It's not a negative. There's nothing for me to distribute here, so this is equivalent to just 3x plus 10. And on the other side, that's going to equal negative 7x and then minus 70. Okay, so let's add 7x to both sides. So this is going to become 10x plus 10 equals negative 70. And I'm just going to pause and look at it. My intent was to add 7x to each side, and I can see that I did indeed do that. The next thing I intend to do is subtract 10 from both sides. So I'm going to write 10x, and then that's going to equal negative 80. And I'm just pausing to check that I indeed subtracted 10 units from both sides, and I did. Each side had 10, and I took it away. And then I divide both sides by 10. So divide the left-hand side by 10, I have x. Divide the right-hand side by 10, I've got negative 8. So I think I know what x is. I believe x is negative 8. And I'm just going to plug that value in to the second equation. And when I plug that in, that's going to become y will equal negative 8. That's what I found x to be, plus 10. So y equals the number 2. So my solution here is that, and I'll always write it as an ordered pair, well, especially if I've got the variables x, y, right? Y is, x rather, is negative 8, and y is 2. So again, thinking about this big picture, there is two graphs here. I can put them both in y equals form and graph them. The one place where they share an intersection, the one value that makes both of them true, is the point x is negative 8, y is 2. And remember, it's possible that these two lines could be parallel and they wouldn't have a solution. There's not a point where they do meet, but these two do meet at this location. And if I plug in this value, I could plug in the value into the top equation. 2 times negative 8, right? 2 times negative 8 would give me negative 16, and then plus 2. So that side becomes negative 14. And on the other side, I've got negative 7 times 2, which is also negative 14. So I can see that it does indeed satisfy the top equation, right? When I put in the point negative 8, 2, it makes both sides of that equation 14, so that's a solution. And for the second equation, I know that that works because that's literally how I got the y. If I plug in y is 2, and on the other side I write negative 8 plus 10, I can see, yeah, negative 8 plus 10 is 2. So solution is x is negative 8, y is 2. Let's move on to the second system rather. This system, it's awfully close to being doable as an elimination problem. So I'm going to choose that. I am going to take the top equation, and from each side of that, I'm going to add 5y. So it's important to note that when you add 5y to the right-hand side, right, you're left with nothing. And a lot of times I'll accidentally do that. I'll say, oh, let me move the 5y over, and I forget, oh, there's nothing there. So you can see I had two sides of the equation, the top equation, and on each side I added 5y. So that gives me 3x minus, it was 3x plus 5y, and on the other side it's negative 5y, and 5y gives me just the 0. And then the bottom equation is still 6 times x minus 7y, and that is 17. So now I'm much closer to setting this up using elimination. I'm going to choose to take the top equation and multiply all the terms on both sides of that equation by negative 2. So I'm just pushing this factor of negative 2 onto this term, and this term. And when I do that, this equation, again, they're factors, so I'm multiplying here. This top equation is going to become negative 6 times x, and then negative 10 times y, and that equals 0. 0 times negative 2 is still 0, but I did multiply by it. It just didn't have an effect. And then the second equation is still 6 times x, not plus, minus 7y is 17. All right, so now I can see that I have equal things, right? If you have equal things, check, and you add equal things to both sides of that, yeah, and these things are equal, you'll get equal things. So the addition property of equality tells me now if I combine these things on the left-hand side, I'm going to get negative 17y, and on the right-hand side, I'm going to get 17, which means that y is the number negative 1. And now that we know what y is, we can plug that in and figure out what x is. And I think I'm going to choose to take the top equation, although both would give me the same value. If I take that top equation, it's going to be 3 times x plus 5 times negative 1 equals 0. So I'm going to add 5 to both sides, so 3x is 5. And I'm going to divide both sides by 3. So x is 5 thirds. All right, so we now have x, we now have y, so we can go ahead and write our ordered pair. 5 thirds is x, and y is negative 1. And again, it's always a good idea to go back and just check that with the original system and see that you haven't created some kind of goofy error. So if I was to plug 5 thirds into the top equation, 3 times 5 thirds would give me just 5. And then on the other side of that top equation, negative 5 times negative 1 would give me a 5 also. So I can see that the first equation works. And in the second equation, 6 times 5 thirds would be 30 thirds, which is 10. 10. And then minus 7 times negative 1 looks like 10 plus 7, which looks like 17. So you can see that, yes, both the right-hand side and the left-hand side are 17 when I plug in this point. So my solution to part B is x is 5 thirds, y is negative 1.